This section is about moments and what causes things to slip. So you're climbing up a plank of wood which is leaning against a tree in order to get high enough up to pick some fruit. However, when you climb, the plank slides down the tree. What's going on here? It's called slipping, and it happens when the frictional force keeping the plank where it is no longer enough to prevent sliding. Let's talk about forces for a bit. They're difficult to imagine because you can't see them. Think of trying to push an object along a horizontal table. The object is still, so the total force on it is 0. There's weight acting downwards, balanced by an equal and opposite reaction force from the table, acting upwards. There's the horizontal pushing force that you are applying, and this must be balanced by another horizontal force acting in the opposite direction. This force is called static friction. The object isn't moving, so you gradually increase the force that you apply. What happens? Firstly, the friction force increases to match the force that you apply. Then the object starts moving once the friction force can't increase anymore. This maximum frictional force is known as the limit of static friction and is governed by how heavy the object is, it's harder to push heavier things, and what sort of surface your object has and is on. It's harder to push across a rough surface. A similar thing happens on a sloping surface. As you increase the slope, eventually the component of weight acting down the slope overcomes the static friction and the object begins to slide. So, back to our plank of wood. What forces are causing it to slide down the tree? This example is more complicated because we need to consider where the forces are acting and not just how big they are. That is, we need to consider moments as well as forces. Up till now, we've been balancing forces by assuming that they all act at one single point. What happens when they don't act at one point, even if they cancel each other out in terms of size and direction? Or we get turning or rotation. To move on, we need to define what a moment is. A moment of a force about a given point is just the force multiplied by the distance from the point to the force. However, we need to be very careful about what we mean by distance. Being exact, we say that the moment of a force about a point is the force times the perpendicular distance from the point to the line of action of the force. Now we've come up against another thing that needs defining, the line of action. The line of action of a force is just the straight line which passes through the force in the same direction as it, but carries on forever in each direction. Returning again to our plank of wood leaning against a tree, the forces acting are the weight acting in the middle vertically downwards, the friction acting horizontally, and the normal force acting vertically, both at the bottom of the plank of wood, and then the reaction force between the tree and the plank of wood. Now we consider the moments, the turning forces about the contact between the plank and the tree as we decrease the angle of the plank. The perpendicular distance of the weight and the normal reaction to the tree-plank contact get bigger, increasing their moment, whilst the perpendicular distance from the frictional force to the tree-plank contact gets smaller, meaning that the friction must increase to counteract the clockwise moment. Eventually the angle is too small and we reach the limit of static friction. The friction can no longer increase and the plank slides to the ground. We conclude that, to reduce the chance of slipping, you need to lean the plank of wood at a steeper angle to the tree. Static friction stops things from slipping. When it reaches its maximum value, objects begin to slide.